Now, how can we say whether a reaction will take place or not? How we will predict whether a reaction will take place or not? In order to predict whether a reaction will take place or not, whether it is thermodynamically feasible or not, for example, it says, is the following reaction thermodynamically feasible? Feasible means possible or favorable. We can say feasible or we can say favorable. And they gave us this reaction that zinc metal plus copper ions gives zinc ions plus copper metal. And they want us to predict whether this reaction will take place or not, whether it is feasible or not. So what are we going to do? We have these two half cells, that the zinc ions plus 2 electrons gives zinc metal, and that the copper ions plus 2 electrons gives copper metal. And of course, from the data booklet, we will see that the E node value for the zinc ions zinc electrode is negative value, and that of copper ions plus 2 electrons gives copper is a positive value. What are we going to do is we are going to place these two half cell equations. We are going to place the one that has the more negative value first and then the other. We are going to place them in this way, that the standard electrode potential that is having the less positive value is going to be written first, and then the one that has the more positive standard electrode potential. And we will see that the species that is present on the top right of these two equations, the one that is placed at the top right, would react with the one that is placed on the bottom left. This means that if we arrange these two equations so that the one that has the less positive value or the more negative value for standard electrode potential, we place it on top, and the one that is having the positive value or the less negative value, we place it at the bottom, then we will say that the species that is present on the top right would react with the species that is present on the bottom left, which means that zinc would react with copper ions to form zinc ions plus copper. So the reaction will be feasible because zinc, here at the beginning, they asked us whether this reaction is feasible or not, that zinc reacts with copper ions to form copper plus zinc ions. Yes, this reaction is feasible. Why? Because when we placed these two equations so that the one that is having the less positive value or the more negative value up and the one with the more positive value below, then always the species that is present on the top right would react with the species that is present on the bottom left. So yes, zinc would react with copper ions to form zinc ions and copper metal. We say that this reaction is thermodynamically feasible or thermodynamically favorable. Okay. Now here it says, will zinc react with dilute sulfuric acid? Will zinc react with dilute sulfuric acid forming zinc ions plus hydrogen gas? Then we look at the two equations in the data booklet. We will find that it's written zinc ions plus 2 electrons gives zinc metal. The E node value is minus 0.76 volts. And the 2 hydrogen ions plus 2 electrons gives hydrogen gas E node value equals 0. We said that always the half cell equations are written in the reduction form. You will find it in this way in the data booklet. So they asked us to determine whether zinc would react with hydrogen ions. So when we arranged them in the order that the more negative standard electrode potential comes first and then the less negative or the more positive, then we can deduce that zinc, which lies on the upper right, would react with the hydrogen ions that are present on the lower left. So zinc can react with hydrogen ions to form zinc ions plus hydrogen gas. So yes, this reaction is feasible because when we arrange them in this way, then zinc will react with H positive, forming zinc ions plus hydrogen gas. Yes, this reaction is feasible, is thermodynamically feasible or favorable. Understand?
Okay, monsieur.
Okay, it says here, will copper react with dilute sulfuric acid? Will copper react with dilute sulfuric acid? Now, we are going to arrange them, the more positive down and the less positive up, as we used to do, because here they did the opposite arrangement. But it says, will copper react with dilute sulfuric acid? So we are going to write the more negative or the less positive up. So here I'm going to write 2H positive plus 2 electrons gives hydrogen gas. This is the less positive. And I'm going to write copper ions plus 2 electrons gives copper metal. As this is the more positive, it is plus 0.34. I'm going to write it below the upper one, which is 0 volts. This is the less positive. So I must write it upward. And this is the more positive, should be written downward. And this means that the species that lies on the upper right would react with the species that lies on the lower left, isn't it? So hydrogen gas would react with copper ions to give hydrogen ions with copper, not as they wanted us to find out. They said predict whether copper solid would react with hydrogen ions to form copper ions and hydrogen gas. No, it should be the opposite. That hydrogen gas is the one to react with copper ions to form hydrogen ions and copper, according to our arrangement here. We arranged the one having the less positive E node value at the beginning, and then the one with the more positive value, so that we can say that the upper right would react with the lower left. So when we did so, hydrogen should react with copper ions, not copper metal react with hydrogen ions. It would be the opposite. Understand? But if even we say that from this arrangement, that hydrogen gas would react with copper ions to form copper plus 2 hydrogen ions, although it is thermodynamically feasible, as we say, although it is thermodynamically feasible, the reaction between hydrogen gas with copper ions, yet this reaction does not take place. Although it is thermodynamically feasible, yet the reaction between hydrogen gas and copper ions does not take place. Why? When we have a reaction that could be thermodynamically feasible, but really it does not take place, we say that it is kinetically unfavorable. It is kinetically unfavorable. What do we mean by kinetically unfavorable? If you remember, when we used to draw the energy level diagrams, we used to find here what we call the activation energy. This is called the activation energy, and that the reactants should have energies equal to or greater than the activation energy in order to form the products. So if we have a reaction that is thermodynamically favorable or feasible, but it does not take place, this means that the activation energy of this reaction is very high. It is very high. The activation energy is very high. That's why we say that the reactants are kinetically stable. Kinetically stable. It means that although the reaction can take place, yet the reactants are kinetically stable because the activation energy is so high, so they prefer to be left as they are and not form the products. Understand what I mean, or shall I explain it once more?
Yeah, miss, once more. I lost.
Okay. Now it says predict whether the reaction between copper and sulfuric acid would take place. Okay, so we are going to write the two half cell equations. From where are we going to write them? We are going to write them from the data booklet. So it says that hydrogen ions plus 2 electrons gives hydrogen gas. And we know that the E naught value of hydrogen ions, hydrogen gas, is equal to 0 volt. Okay, and that the copper ions plus 2 electrons would give copper metal, where the E naught value of copper ions, copper metal, equals plus 0.34 volts. Okay, we found these two equations, and I arranged them in such a way that the less positive, I wrote it first, and then the more positive. Understand till here?
Yes.
Okay, what does this mean? What will react with what? According to this arrangement, what would react with what?
What, miss?
What will react with what according to this arrangement? Which species would react with what, or which species?
The copper with hydrogen, right?
No, it's the hydrogen gas would react with the copper ions. We said that the species that is present at the top right reacts with the one that is present in the bottom left, isn't it? Yes, or no?
Miss, can you hear me?
Yes, I hear you.
I said it, miss. I said
no,
yes.
No, you said copper. You didn't say copper ions. You didn't say copper
okay,
ions.
Miss, copper. Okay,
Yes,
miss, copper
ions. Yes, excellent. So the hydrogen gas would react with the copper ions according to this equation. Not that the hydrogen ions of sulfuric acid reacting with copper metal. When they said predict whether this reaction between copper and sulfuric acid takes place, we say no. They wanted us to find out whether copper metal would react with hydrogen ions to form copper ions plus hydrogen gas. No, this reaction will not take place. Why? Because when we arranged the two half equations so that the one with the less positive value, we arranged it at the top, and the one with the more positive value, we arranged it at the bottom, this means that the one that is present on the top right would react with the one that is present with the bottom left, and not the opposite. They wanted this reaction, copper reacting with hydrogen ions. So this reaction will not take place. But as we considered, we said that according to this preparation, this means that copper ions would react with hydrogen gas, forming hydrogen ions plus copper metal. And we say that this reaction is thermodynamically favorable. Thermodynamically favorable or feasible. Favorable or feasible, which means that it was expected that this reaction will take place. But really, it didn't. It did not take place. Why? Because there is another factor affecting whether the reaction would be feasible or not. Not only to be thermodynamically feasible, but there is another factor which is the kinetic behavior. Will it kinetically be favored as well or not? Although it is thermodynamically feasible, but kinetically it is unfavorable. Kinetically it is unfavorable or unfeasible. Why? Why is kinetically it is unfavorable? When a reaction is kinetically unfavorable, it means that the activation energy for the reaction is so high. It has a very high activation energy. Activation energy is so high, so that the reactants will not be able to cross this energy barrier to form the products. When a reactant forms a product, it must cross this energy barrier by having energies equal to or greater than the activation energy, isn't it? When we draw delta H against the reaction pathway. So if the activation energy is so high, we say that the reactants are kinetically stable. The reactants are kinetically stable. It means that they will not be able to form the products even if the reaction is thermodynamically feasible. Even if we use the standard electrode potentials, we find that it can take place, this reaction can take place, but sometimes it doesn't. So why did it not take place? Because it is kinetically unfavorable, or that the activation energy is so high that the reactants are kinetically stable. That's why the reaction will not take place. So the first reaction, when they asked us to predict whether the reaction between copper and sulfuric acid would take place, we found it not. Why? Because when we arranged the half cell equations, depending on the less positive first and the more positive below it, we found that hydrogen ions cannot react with copper metal as they wanted us to predict, because it will be the opposite, that the hydrogen gas reacting with the copper ions. But even that the reaction between hydrogen and copper ions is thermodynamically feasible, yet this reaction does not take place as it is kinetically unfavorable, where the activation energy is so high, and so the reactants, copper ions and hydrogen, are kinetically stable, and they are not going to produce hydrogen ions and copper metal. If you don't understand, please tell me. I will explain it once more.
Miss, I do.
Yes, you don't?
No, Miss, I do.
You got it? Okay. So when they said, will copper here it says, will zinc displace copper when added to an aqueous solution containing copper ions? Will zinc displace copper when added to an aqueous solution? It means, will zinc displace the copper ions, forming zinc ions and copper? They are asking us the question, will zinc displace copper when added to an aqueous solution containing copper ions? So what are we going to do? They ask us this question, will zinc displace copper when added to an aqueous solution containing copper ions? This equation, will it take place or not? So what are we going to do to know?
First, we're gonna have to take the equation and split it into two half equations.
Yes. We will
And
find
then
every two similar together, zinc and zinc ions, and copper ions with copper. We are going to take every two similar together, and we are going to open the data booklet and then write what?
we're gonna write half equations, right?
Yes, half equations, but how they are going to be arranged. Which one is going to be written first and which one is going to be written below?
Zinc is gonna be written first.
Yes, why? Excellent, why?
The E note's less.
Yes, excellent. Because we write the less one up and we write the more one, the more positive below it. Now, from this arrangement, will zinc react with copper ions or not?
What, Miss?
Will zinc react with copper ions or not according to this arrangement?
Yes, it will.
Why? Because what reacts with what? According to this arrangement, what does react with the other? Which species react with the other species? How are we going to choose them?
Almost, is it gonna be like
Yes.
The zinc solid will react with the copper ions.
Yes, why? Because we choose what? We choose, from where did you know that? What did you choose? You have chosen the one on the top right, reacting with the one on the bottom left, isn't it?
Yes.
So this means that yes, zinc can react with copper ions because zinc is present on the top right and copper ions are present on the bottom left. So yes, they can react together. Okay. And in order to find out the E naught cell, we start with we said that E naught cell equals E right minus E left. The E right is the one that gains electrons. The one that when gains electrons gives a positive value. So this is the E right. So it's plus 0.34 minus the one that loses electrons. The E left means the one that loses electrons, which is the zinc that loses electrons. So this is the E left. So we write minus 0.76, and then we add them together. It becomes 1.1 volt. Okay.
Okay.
Right. Let's see another worked example. It says, will copper produce hydrogen gas when added to dilute sulfuric acid? Will copper produce hydrogen gas when added to dilute sulfuric acid? This is copper and this is sulfuric acid. Will it produce hydrogen gas when added to sulfuric acid? We said that we are going to arrange of course, we arrange the one with the less positive upward and the other downward. We will see that it's the hydrogen gas that is going to react with the copper ions, not the opposite. But what if I made wrong and I put the copper ions plus 2 electrons gives copper solid, E naught is plus 0.34 volts, and that 2 hydrogen ions plus 2 electrons gives hydrogen, E naught equals 0. Maybe I did something wrong and I put the copper ions first, the half equation of copper first. So the E naught cell will be what? We have here the E naught cell for if copper is the one to react, this means that the opposite equation took place, that copper released electrons forming copper ions, and since we reverse the equation, then the E naught value also, its sign will be opposite. Instead of being positive, it will be negative. And the hydrogen ions is 0. So if we add them together, we get a negative value. When we got a negative value, this means that this reaction cannot take place because the E naught cell is a negative value. Okay. So if we want to find out whether copper will react with 2 hydrogen ions, then we are going to arrange our equations so that copper comes as the reactant. So here I'm going to reverse this equation so that copper comes as the reactant.
So we're gonna have to
yes.
No, miss, we're gonna have to flip the equation and the hydrogen one will be up and copper down.
Yes, but if by mistake I remain them as they are, and they said predict whether copper will react with H positive. So I look at this equation and I see that the copper is present as a product, but here it is present as a reactant. So we are going to flip the equation to get the copper as a reactant, isn't it? If I want to try to get the copper as the reactant. So I flipped the first equation so that the copper becomes a reactant, like is what he wanted me to have. As I flip the equation, then I must flip the sign of the E naught value. Understand?
Yes, miss, understand.
And then we want the hydrogen ion as a product, as a reactant, and it is also present here as a product. So I'm going to place it here. 2H positive plus 2 electrons gives hydrogen gas, and the E naught is 0. So if I add these two equations, the electrons will cancel, and we have copper plus 2H positive gives copper ions plus hydrogen gas. So I got my equation. But when I added the E naught values, I got them to be minus 0.34 volts. Since I got a negative value, this means that this reaction is not feasible. For any reaction to be feasible, the E naught cell must be a positive value. Okay?
Yes, miss. So, miss,
Yes.
in the exam itself, they would give us questions like this and ask us if it is feasible or not.
Yes.
But will they ask us also how to make it feasible?
Yes. We are going to take this after a minute. Yes.
Okay.
Okay. Here, this is what you were asking about. Here, they are taking the reaction between manganese 4 oxide and hydrochloric acid. The reaction between manganese 4 oxide and hydrochloric acid. They said that one method of preparing chlorine gas in the laboratory is to react manganese 4 oxide with hydrochloric acid, according to this equation. Manganese 4 oxide solid plus 4 HCl aqueous gives manganese plus 2 iron aqueous plus 2 chloride ions plus 2 water plus chlorine gas. So we get chlorine gas from the reaction between MnO2, which is manganese 4 oxide, and hydrochloric acid. Now, we want to see whether this reaction is feasible or not. So what are we going to do? We are going to see where are similar ions or similar species. So here I have MnO2 with Mn plus 2. Okay, and I have HCl with chlorine. Okay, and I look in my data booklet about manganate with Mn, manganese dioxide with Mn plus 2. I look in my data booklet for an equation relating the MnO2 with Mn plus 2. Okay, so this is the equation. I get it from my data booklet that MnO2 solid plus 4H positive plus 2 electrons gives Mn plus 2 water. So I got this equation. This is equilibrium 1. And we find that E naught value is plus 1.23 volt. Okay, now the other equation is going to relate the chlorine gas with the chloride ions, because HCl is ionic, it will ionize in solution. So we will get an equation, a half equation relating the chloride ions with chlorine. We get Cl2 gas plus 2 electrons gives 2 chloride ions. Cl2 gas, we get this equation, and we get the E naught value to be plus 1.36 volts, and this we call it equilibrium 2. We are going to arrange the two equations as we used to do, the one with the less positive value first and the one with the more positive value second, and we will see that manganese ions would react with chlorine gas and not the opposite. They want us to prepare chlorine starting from MnO2. But if we arrange the two half equations in this way, the less positive first and then the more positive, we will find that Mn plus 2 is the one to react with chlorine gas, not MnO2 reacting with chloride ions to form chlorine gas. Understand what I mean?
No, miss. No, I don't.
You don't get it?
No.
Okay, I have to write the equations outward because I will not be able to remember all these equations. Okay, MnO2 plus 4HCl gives Mn plus 2 chloride plus 2 H2O plus Cl2. I'm writing the equations in order to go to a whiteboard. Okay. Here it says that in order to prepare chlorine gas, one of the methods in order to prepare chlorine gas is the reaction between manganese 4 oxide plus HCl. And from this we get manganese plus 2 chloride ions plus 2 water plus chlorine gas. So this is the method to prepare chlorine gas starting from manganese 4 oxide plus hydrochloric acid. Okay. Now we want to know, is this reaction feasible or not? Is it feasible or not? So what are we going to do? We are going to start with MnO2 and Mn plus 2 and look in our data booklet to see an equation relating the manganese 4 oxide with the Mn plus 2. So we are going to find an equation that says that MnO2 plus 4H positive plus 2 electrons gives Mn plus 2 plus 2H2O. And we find that the E naught value for this half cell is equal to plus 1.23 volts. Okay. And then we want to find a relation between the chloride ions and chlorine gas. We'll find this relation that chlorine plus 2 electrons gives 2 chloride ions. And we find that the E naught value for this equation equal plus 1.36 volts. Okay. Now we want to find out, will this reaction take place, that the manganate 4 oxide react with the chloride ions? We have these two equations. When we arrange them so that the one with the less positive value, we put it on the top and we wrote the other one on the bottom because it has more positive value. So according to this arrangement, which species is going to react with which species? Yes.
The Mn and Cl.
Mn and Cl. Where is the Mn and where is the Cl?
The Mn2 plus is
yes.
the top right. And
yes. So we say the Mn plus 2 reacting with? We react with what?
Cl2.
With Cl2. So this reaction is feasible, that the Mn plus 2 would react with Cl2, but they don't want this reaction. They want the opposite one, that Mn2 reacts with HCl to form Mn plus 2 and chlorine gas. They want the Mn plus 2 and the chlorine gas to be products, not reactants. These are reactants. When we write in this way, this means that the Mn plus 2 and the chlorine are the reactants, not the products. We want them to be the products. Okay? Which means that this reaction at standard conditions, because all our reactions are at standard conditions, this reaction is not feasible. The upward reaction, which is the reaction between MnO2 plus HCl, is thermodynamically not feasible, or it is unfavorable. Okay, understand till now, or do you want me to repeat?
Understood.
Okay, now we want to let this reaction happen. We want to force it to happen because we want to prepare chlorine. I don't want chlorine to be a reactant. I want it to be a product. So what am I going to do? So
you're going to rearrange the equation.
No, we are not going to rearrange, but what are we going to do is that we have equilibrium reactions, isn't it? And we know that equilibrium would be affected if I change the concentration of any of the reactants or the products. It means that if I used a more, all the ions here have concentrations of 1 mole per decimeter cube. All ions have a concentration of 1 mole per decimeter cube as related to standard conditions. We said that standard conditions means that the hydrogen ions, the chloride ions, and the Mn+2 ions, all of them should be 1 mole per decimeter cube. These are standard conditions. So in order to let this reaction take place, we are going to change the concentration of HCl. Instead of being concentration of HCl, we are going to change it. Instead of being 1 mole per decimeter cube, we are going to be, let it, the concentration of HCl, let it be 10 mole per decimeter cube. It means that it's no more standard condition. It's in a non-standard condition because we increased the concentration of HCl from 1 mole per decimeter cube. When we write H positive and chloride negative, it means HCl. So we changed. If we change the concentration of HCl to be 10 mole per decimeter cube instead of 1 mole per decimeter cube, what will happen? If I look at the first equilibrium here, if we write this, the first equilibrium, and this is the second equilibrium, we will see that when I increase the concentration of HCl, this means that the hydrogen ion concentration will increase. So what will happen to the equilibrium? Will it shift more towards the right-hand side or will remain the same? I will repeat. If I change the concentration of HCl, instead of 1 mole per decimeter cube, I'm going to make it 10 mole per decimeter cube. This is no more standard condition.
Towards the left.
Yes, it will shift towards the
left.
The left. It means that it will return back. This equilibrium.
No, see, you will add more concentration
of HCl.
On the reactant side, right?
I added concentration of HCl 10 moles per decimeter cube, which means that the H positive concentration will increase. So where will the equilibrium shift?
Reaction will shift to the right.
Yes, it will shift to the right-hand side, isn't it? It will shift towards the right-hand side. And when it shifts to the right-hand side, does this mean that the E naught value will remain the same or will it increase?
It will increase.
It will increase. So the E naught, no more, it's not going to be called E naught because it's non-standard conditions. We will say that the E value will be more positive. For example, it will be, 1.5 volts. It increased. Okay. Understand till now?
Yes.
Okay, but when we increase the concentration of HCl, this means that the chloride ion concentration also increases because HCl means H positive and chloride negative. So when we increase the concentration of HCl, this means that both the hydrogen ions and the chloride ions increase. So what happens in the second equilibrium when we increase the concentration of the chloride ions?
The concentration will increase, so the reaction will shift towards the left.
Yes, excellent.
And the E naught will increase also.
It will decrease. The E naught value will decrease because we shifted towards
the reaction to the left. Yes,
we shifted the reaction to the left, so the E naught value will decrease. And so the new E value will be, for example, plus 1.3 volts. Okay. Understand?
Yes,
so when this increased and this decreased, and we are going back to arrange them in the new arrangement, the one with the less positive is written first. So we write chlorine plus 2 electrons gives chloride ions. It's going to be written first because now it has the smaller positive value. And the other one that has the higher positive value will be written downward in that way. The E naught value will be more positive. So now which species is going to react with the other?
Miss, did you ask me a question?
Yes. Now, when we wrote the equations in that way with the new E values, now which one, which species is going to react with the other?
The 2Cl.
Yes. The chloride ion
Mn
is going to react with the MnO2.
MnO2.
Yes. So this equation or this reaction will take place, that the MnO2 will react with the chloride ions, forming chlorine gas and Mn+2. And in this way, we will force the manganate 4 oxide to react with the HCl to give the chlorine gas in order to prepare it by this method. We changed the conditions. We changed the standard conditions. Instead of using hydrochloric acid with a concentration of 1 mole per decimeter cube, which is a standard condition, we change it to another concentration, which is a higher concentration, 10 mole per decimeter cube. And in that case, we do not react them at standard conditions. These are non-standard conditions, but we forced the above reaction to take place to prepare chlorine, starting with manganese 4 oxide with HCl. Understand? Do you have any question?
Yeah, misunderstood.
Okay.